Hey everybody, this is video 2. It's going to be on chemical and physical properties and chemical and physical changes. So make sure you've got your follow along sheets and let's get to it. Let's talk about physical properties first. A physical property, like it says here, is a property that can be observed without changing the identity of a substance. For example, in this picture here of this water, I can tell that it is blue, the color is blue, without having to change it in any way. The color blue is a physical property in that instance. Down here, we've got a piece of metal sitting on a balance with a mass recorded there. That piece of metal's identity did not change in order to find out the property of mass. Here's a paper clip that's been bent. When it was bent, it was still a paper clip. Nothing new changed. The ability to bend, malleability, is a physical property. Even a physical change here, like the boiling of water. I mean, what's the chemical property? What's the chemical formula for this liquid water? Of course, it's H2O, and then when it boils and becomes water vapor, it's still H2O. So a physical property like the boiling point of water at 100 degrees Celsius. Ice melts at 0 degrees Celsius. That's a physical property. Phase changes are physical properties. See if you can name a couple of physical properties here, at least two. Well, it's a liquid. That's one. It's blue. That's another. Has a volume of about 100 milliliters. That's another one. That's all I can think of right now. But anyway, physical property, the substance's identity does not change. You don't get anything new with a physical property. A chemical property, however, you can only observe chemical properties by something about the identity of the substance changing. For example, flammability, the ability of something to burn, is a chemical property. The identity of the substance changes. We always get something new and something burns. The ability of iron to react with oxygen to rust. That is a chemical property of iron. Here we've got a piece of sodium that was dropped into a container of chlorine gas, and energy is released. We can tell by the light here that's a chemical property of sodium when it's placed in chlorine gas. That's how it reacts. So like it says down here, you can't just look at a substance or touch it to determine its chemical properties. Somehow its internal structure must be changed or affected. So take a second here and take a look at these and identify these as either chemical or physical properties. Think about whether or not a new substance would get formed. Pause if you need to. So we talked about physical properties. Now we're going to talk about physical changes. And a physical change is any change that does not involve the substance's identity changing. Like, for example, here we actually had two physical changes occurring. Of course, the ice is melting, the solid water is becoming liquid water, but that liquid water is also in the process of evaporating. So those are two physical changes happening right there. Here, making orange juice out of the oranges, we're not creating something new. It's still the pulp, the orange, all that stuff is still there. Just its structure has changed, but it's still recognizable as orange juice. Over here, we've got a piece of metal that is being bent, and that is a physical change. When this wire is bent, nothing new is created. Down here, we're tearing a piece of paper. Obviously, no new substance is created when that paper is torn. But when we have a chemical change, then the substance's chemical identity changes and we get something new that wasn't there before. Burning or combustion is always a chemical change. When something burns, we always get something new. Cooking. You may not have thought about that as a chemical change. Most of the time it is. Like when you boil an egg, a new substance is formed. Here's some Alka-Seltzer or some kind of antacid dissolving in water, and you can tell by all the bubbles there that we get a new substance formed. That's a chemical change. When you put sulfuric acid and sugar, you get this thing created here that's mostly carbon. And up here, this yellow liquid wasn't there at the beginning. It was a solution of sodium chloride and lead nitrate were mixed, and it formed this yellow precipitate. So those are all chemical changes because something new was created. In other words, a chemical change happens when a chemical reaction occurs. And how can you tell a chemical reaction has occurred? Well, here are some signs to look for. Most of these all mean that a chemical reaction likely has occurred. For example, if we get a change in color, a change in energy. How can you tell there's a change in energy? It gets hotter, it gets colder, light is produced. All those mean that there's been some kind of change in energy. There's been a change in odor, a new smell when you mix two substances. A gas or solid is formed. How do you tell a gas is formed? Of course, you notice the bubbling. Or the reaction is not easily reversed. It's not something you can just pour through a filter or use distillation to separate like you can a mixture. That's it. Thanks so much.